welcome to Omni. Today, we dive into the darkest depths of the ocean to uncover a truly magnificent biological marvel. Plunging thousands of meters below the surface, sunlight completely vanishes, leaving behind an alien world shrouded in absolute, freezing darkness. In this crushing abyss, survival depends on extraordinary adaptations, pushing the limits of biology to navigate an environment without light. Meet the vampire squid, a mysterious creature that glides silently through the midnight zone, perfectly adapted to this harsh realm. Despite its terrifying name, this gentle scavenger does not drink blood, relying instead on falling organic matter for its sustenance. But what truly sets this cephalopod apart is its incredible vision, possessing the largest eye-to-body ratio on Earth. Imagine having eyes the size of a large dog, proportionally speaking. This extreme adaptation is necessary for spotting faint glows. In an environment where photons are practically non-existent, the vampire squid must capture every single particle of light it encounters. Its massive spherical eyes act like giant light buckets, gathering the faintest bioluminescent flashes emitted by other deep-sea inhabitants. This biological masterpiece is a perfect natural example of extreme sensitivity optics, a concept we utilize in our modern technology. When we look up at the night sky, we face a similar challenge of capturing faint light from distant galaxies. Astronomers and astrophotographers use massive telescopes with enormous mirrors to collect scarce photons traveling across the vast emptiness of space. Just like the squid, if you exist in a dark environment, you must make your primary sensor as large as possible. A camera sensor with high ISO capabilities amplifies minimal light signals, revealing stunning details of colorful cosmic nebulae and stars. The vampire squid achieves this naturally, using an incredibly dense array of photoreceptors to maximize the efficiency of light detection. Each photoreceptor acts like a microscopic pixel, working tirelessly to convert scarce light into electrical signals for the squid brain. The visual cortex of this deep-sea dweller is highly specialized, processing these weak signals to form a coherent image. It is a remarkable feat of evolution, demonstrating how life finds a way to perceive the world in total darkness. Let us examine the anatomy of this extraordinary eye. The large pupil allows maximum light to enter the spherical lens. This lens focuses the gathered light onto the expansive retina, ensuring that not a single precious photon is ever wasted. The retina itself is packed with specialized cells that are exceptionally sensitive to blue light, the most common bioluminescent color. This specific spectral sensitivity allows the squid to easily spot potential predators or floating debris that it can safely consume. In the pitch-black ocean, a glowing silhouette is often the only warning sign of an approaching danger or threat. To understand the scale of this optical power, compare it to the human eye, which struggles in low light conditions. Our pupils can only dilate so much, and our retinas lack the extreme density of rods found in these squids. If we possess the visual capabilities of the vampire squid, a moonless night would appear as bright as early morning. This comparison highlights the incredible diversity of sensory organs that have evolved to suit specific environmental niches across our planet. The deep sea remains one of the least explored frontiers, holding countless secrets about the limits of biological sensory adaptation. Researchers study these magnificent creatures to gain insights that could revolutionize our own optical technologies and low-light imaging systems. By mimicking the structure of the squid retina, engineers hope to develop better sensors for underwater vehicles and space probes. Imagine a deep-sea rover equipped with artificial eyes inspired by the vampire squid, navigating the abyss without artificial lights. This stealthy approach would allow scientists to observe delicate marine ecosystems without disturbing the natural behavior of light-sensitive organisms. Nature has already solved the problem of low-light vision over millions of years of rigorous evolutionary trial and error. We only need to look closely at these deep-sea marvels to find the blueprints for our next technological leaps. The connection between the darkest ocean depths and the infinite expanse of outer space is beautifully illustrated by these optics. Both realms require extreme sensitivity to uncover their hidden wonders, relying on the fundamental physics of light and photon capture. A telescope observing a distant nebula and a squid scanning the ocean floor are engaged in the exact same process. They are both silent observers, waiting patiently for a fleeting glimmer of light to reveal the secrets of the dark. The vampire squid does not actively hunt. Instead, it floats motionless, extending its long sensory filaments to detect passing particles. Its giant eyes constantly scan the surrounding water, providing a crucial early warning system against fast-moving deep-sea predators. When threatened, it performs a unique defensive maneuver, pulling its webbed arms over its body like a dark, fleshy cloak. This posture exposes glowing photophores on its arm tips, creating a confusing display of light to disorient any attacking predator. The squid can modulate these glowing spots, changing their size and intensity to mimic the appearance of a larger animal. It is a master of illusion, using light generation and light detection as its primary tools for survival and defense. The interplay between bioluminescence and extreme visual sensitivity creates a complex visual ecology in the seemingly empty mid-water ocean zones. Every flash, glow, and sparkle carries important information, turning the dark water into a vibrant communication network for marine life. The vampire squid sits at the center of this network, its massive eyes absorbing every subtle signal with perfect clarity. It is truly the ultimate deep-sea observatory, a living telescope designed to monitor the faint biological stars of the abyss. As we continue to develop more advanced imaging technologies, we must acknowledge the superior engineering found in the natural world. The biological lens of the squid is perfectly transparent, minimizing any light scattering that could degrade the final visual image. Furthermore, the arrangement of its retinal cells is optimized to reduce visual noise, a common problem in artificial camera sensors. High ISO settings in digital cameras often introduce grain and artifacts, but the squid visual system filters this out naturally. Understanding this biological noise reduction could lead to software algorithms that dramatically improve the quality of our low-light photographs. The study of extreme sensitivity optics bridges the gap between marine biology, optical physics, and advanced digital signal processing techniques. It reminds us that the solutions to complex engineering challenges are often hiding in plain sight, waiting to be discovered. Or in this case, hiding in total darkness, miles beneath the ocean's surface where human eyes cannot see without assistance. Let us dive deeper into the physics of photon capture to fully appreciate the magnitude of this incredible biological achievement. A photon is the fundamental particle of light, carrying a tiny amount of energy across vast distances through empty space. In the deep ocean, the water absorbs and scatters these photons, making them incredibly scarce the deeper you decide to go. By the time you reach the vampire squid habitat, only 1 in a billion photons from the surface remains visible. To capture these rare events, the squid retina contains a chemical pigment called rhodopsin, which reacts instantly to light exposure. When a single photon strikes a rhodopsin molecule, it triggers a cascading chemical reaction that generates a strong electrical pulse. This amplification process is remarkably similar to the function of a photomultiplier tube, used in highly sensitive scientific measurement instruments. The biological photomultiplier ensures that even the weakest light signal is registered by the brain and translated into actionable information. It is a flawless system of detection, amplification, and processing, all contained within the compact space of a biological eye. As we look back at the history of telescope design, we see a constant push for larger and larger apertures. The James Webb Space Telescope uses a massive segmented mirror to collect infrared light from the very edge of time. Just like the squid, it needs a giant sensor to detect the faint glow of the first galaxies ever formed. The principles of optics remain the same, whether you are observing a distant quasar or a glowing jellyfish swimming nearby. You must maximize your collection area, optimize your sensor sensitivity, and effectively manage the signal-to-noise ratio for clarity. The vampire squid has perfected these principles over countless generations, achieving a level of visual performance that rivals our technology. Its existence is a testament to the power of natural selection to solve the most difficult environmental challenges imaginable today. We often view the deep sea as a barren wasteland, but it is actually a hub of incredible evolutionary innovation. Every creature down here has a unique story of survival, written in its DNA and expressed through its bizarre anatomy. The giant eyes of the vampire squid are perhaps the most compelling chapter in this ongoing saga of deep-sea life. They challenge our understanding of what is biologically possible and inspire us to push the boundaries of our own inventions. Next time you see a stunning photograph of a distant galaxy, remember the silent creature floating in the ocean depths. Remember the ultimate biological sensor, quietly observing its dark universe with unparalleled precision and an unyielding evolutionary grace and beauty. The connection between the cosmos and the ocean is a profound reminder of the universal laws that govern our reality. Light, no matter how faint, is the ultimate messenger of information, carrying the secrets of the universe to those watching. Whether it is the light of a dying star or the glow of a deep-sea predator, the message remains. To receive this message, you must be prepared to look closely, to build the right tools, and to remain patient. The vampire squid embodies this patience, floating in the cold darkness, its giant eyes wide open, waiting for a signal. It is a masterclass in passive observation, teaching us the value of simply watching and listening to the natural world. In our fast-paced modern lives, we often forget the importance of stillness and the power of quiet, focused attention. We blast our environment with artificial light and noise, blinding ourselves to the subtle beauty that exists in the shadows. Perhaps we can learn something from this ancient creature about the art of perception and the true meaning of vision. True vision is not just about seeing things clearly. It is about understanding the context and interpreting the faintest signals. It is about recognizing patterns in the darkness and finding meaning in the seemingly random flashes of light around us. The vampire squid does this every single day, navigating its complex environment with a brain the size of a pea. It relies entirely on its massive optical sensors to make sense of a world that we can barely even comprehend. As we wrap up our journey into the abyss, let us take a moment to appreciate this extraordinary biological marvel. The vampire squid is not a monster, but a beautiful and highly specialized organism perfectly adapted to its extreme home. Its giant eyes are a window into the wonders of evolution and a mirror reflecting our own technological aspirations today. Thank you for joining us on this deep dive into the fascinating world of extreme sensitivity optics and deep oceans. We hope this exploration has opened your eyes to the incredible connections between marine biology, astronomy, and modern human engineering. This has been another episode of Omni Eyes. Stay curious, keep exploring, and we will see you in the next video.